Hello and welcome back to some more geometry fun with Mr. I. And here I am with a picture within a picture. I figured out that I can use my Zoom camera so I can say hi as I am working these questions out with you. So I got my Sabres gear on today, and it is not their destiny to win the Stanley Cup apparently, but maybe it's their density. So today we're talking about volume and density, and maybe you've seen the movie Back to the Future where George McFly says to Elaine, his crush, that you're my density. And he meant to say my destiny. So today we're going to look at density and figure out what it means and how it's connected to volume. But to begin with, let's give you a chance to try this if you haven't tried it yet. Answer each of the questions on the slides before I actually show the answers and go through them. So what do you think about density? Name something that is dense and something that's not dense, and then explain what density means using the objects that you selected. So when you're ready to go on, unpause your video. So I probably came up with two classic examples of something that's dense and not dense. A brick is dense. A brick is hard and is solid, and it is full of matter. It is full of weight. And there's no porousness to it. It's just really compact, and the atoms, not that I'm a scientist, are packed in really, really tight. But a sponge is just the opposite. It's very loose inside, and it's not filled in a solid-like way. It's very light because of all the holes and because of the material, that lighter material that it's made out of. So those are some examples there. And let's get on to some simple examples using students that are sitting in a classroom. So we've got two different classrooms here. Density can be used to describe how compact or populated a space is by looking at, so we're going to look at some examples in 2 dimensions first. So which of the 2 classrooms is more compact or more dense? Classroom number 1 or classroom number 2? Which one has a greater density? It is classroom number 2. There are more students in the room, and even though the classrooms have the same size, there are more students packed into the second one. Now let's actually calculate the density. So to calculate the density, it's the amount of space, it's the amount that's inside the space divided by the amount of space. So in this one right here, there's 8 students, or 8 people in the one classroom. So the density could be 8 people per room, or if you wanted to say how many people were there in the area, you could figure out the area of this classroom. It's base times height, 30 times 20 is 600 square feet. So you could say that the amount of people per square foot is 800 people per 600 square feet. And if you do the division there, it comes out to be 0.013, repeating, people per square foot. Do the same thing for this one here. There's 12 people per room. So the density could be expressed as 12 people per one room. Or if you did it in terms of the square feet, it's 12 people per 600 square feet of space, which comes out to be so the density comes out to be 0.02 people per square foot. Now the word per in math is one way to express the word division. So whenever you hear of a percent, or it's 75 cents per ounce, when you hear the word per, it means, and if you're going to calculate with the word per in math, you're going to be dividing. So those are some examples and that's showing that this one has a higher density compared to this one, technically, if we figured out the actual density as a number. All right, so this is a next example is with a science class where they're actually examining bacteria in two petri dishes, which are little, well, they're like little plates that hold the experiments, and they're looking with their microscope. And I don't know how they can count up how much bacteria there are, but there must be techniques that they can use to figure out how much bacteria is on the plate besides counting one at a time. So why don't you try question 4 without any help, and then I'll show you my answers when you're ready. All right, looks like a lot of work, but not really. So in this question here, we'll just focus in on just one of the petri dishes first. So they're telling me that the diameter of petri dish A was 51. That means the radius is 25.5. Why would I need to figure out the radius? Well, I need to know how big the plate is, and the plate is the area of the petri dish. So it would be pi r squared for the area. If I calculate the area, it comes out to be a little bit more than 2,000 square millimeters. Now, they didn't want to know the area. They wanted to know what the density is for the bacteria. So the density is how much is actually in there. So just like the classroom. But here, instead of it being students, they're like little tiny specks. So there's 40,000 little specks of bacteria in this space right here. So I'm figuring out how much bacteria there is per square millimeter. So I'll take the total number that are inside the circle and divide it by the area, and look at that measurement. It comes out to be about 20 bacteria per square millimeter. So that means each little 1 millimeter by 1 millimeter square on that plate has about 20 little bacteria in them. In a very similar way, you could figure out the answer to Petri dish B. To officially answer this question, it says determine and state which Petri dish has the greater population. So you'd have to say, comparing these two, you'd have to write out on your test paper or communicate that dish A had more bacteria. As silly as it is on a state test or some sort of exam, if you did not say it is Petri dish A that has more, then you wouldn't get full credit because you did not technically answer the question. So moving from two-dimensional shapes to three-dimensional shapes, we can actually answer questions like number 5 and figure out how heavy these solid objects are, or these containers are. So giving question number 5 a try on your own without any help first might be a good idea. See if you can figure out how much this container weighs. And then we'll do the question live in just a second. So give it a try first if you haven't tried it yet. And unpause your video when you're ready. All right, so I want to know what the weight is. I got to take a look at all this information. They're telling me how many pounds there is per cubic foot. So it's a quarter pound. The abbreviation for pound is LB. I don't know why it's LB, but I'm sure Google knows or Alexa knows if you ask it. So it's 0.25 pounds per every single cubic foot. So if I want to figure out what the weight of the container is, I need to multiply this by a fraction or by something that has cubic feet as the numerator so that the cubic feet will cancel. So I can think about it that way right from the start. Another way to think about it right from the start is they're giving me a length, a width, and a height. and they're giving me a container that's shaped like a rectangular box. So very quickly I could do length times width times height, and maybe that's the way that you could start this question. So there's lots of different ways you can start the question. You can jump right into it, or you could think about what you'll need. So I'm trying to figure out the volume, and if I find out the volume, I can multiply it by the fact that there's a quarter pound in every 1 cubic foot of space. So 4 times 8.5 times 12 would be 408 for the volume, 408 cubic feet. You can see that it's one of the answers here, but we're not looking for the volume, we're looking for the weight. So every one of those cubic feet has a quarter pound in it. So multiplying those two together would get me that the object weighs about 102 pounds total. All right, moving on to some more examples here. So let's lower this down so you can see that. So in science, they often are pretty specific about using the idea of mass instead of weight. Your weight on Earth, I'll explain it this way, your weight on Earth is not the same as your weight on other planets. So they've determined that there's a way to measure your mass, or how heavy you are, not necessarily in pounds, but in grams or kilograms. And that would be a universal measure of how much you weigh actually, or how much mass you actually contain. So, and there's also a fact, I've seen it before on plates at the gym, smaller plates. It says that, that there would be 2.2 pounds in every kilogram. And you can see sometimes on if you're working out at the gym, you'll see the different plates, and it'll tell you how many pounds it is, and then right on the same metal plate, it'll tell you how many kilograms that the barbell has, or the plate has on it. So we're going to use that information here to figure out some things about a tree. So why don't you try question 6A and even question 6B. And unpause the video when you're ready to see some solutions. All right, so looking at this question, we've got a tree trunk, which we'll say is approximately a cylinder. It's not a perfect cylinder, but then we've got the trunk of a tree. We know that its circumference is 4.5 meters, and we know that the height is 8 meters tall. So maybe it's obvious in the unit that we're studying that you're going to be figuring out the volume of this tree trunk based on the fact that we're going to try to figure out how many cubic meters of wood is actually in that tree trunk. So figuring out the cubic meters will help us unlock the answer to our question, which is how heavy it is in kilograms, and eventually how heavy it is in pounds. So we're going to figure out the volume here. To figure out the volume of a cylinder, it's pi r squared times h. And we're sitting on the height. We know the height is 8, but we have a problem. We don't know what the radius is worth. And that's where the circumference is going to help us out. So the circumference formula is pi times d. And if the circumference was 4.5, we know that 4.5 is equal to pi times d. Using that formula, we can figure out what the diameter is by dividing by pi. And that's a start. That'll give me the diameter. 4.5 divided by pi ends up being about 1.43. Just did it on the calculator. 1.43. Now that's the diameter. I don't need the diameter, I need the radius. So the diameter is all the way across the circle, half of the diameter would be the radius, which comes out to be about 0.716. Hey, it's our area code, the 716. So we get volume is pi times 0.716 squared times the height, which is 8. So typing that all into the calculator, squaring that radius, multiplying it by pi, and multiplying it by 8. We get that the volume is about 13. And you can see that they've tried to trap me on this question by putting 13 there as one of the choices. And that's the volume in cubic meters. And a cubic meter is about the size of my desk here that I'm sitting at right now. It's about a cubic meter right there. So there's about 13 cubic meters of wood in this tree. So now they want to figure out how much the tree weighs in kilograms, and that's where this second number comes in. But there are 752 kilograms in every cubic meter. So remember, the word per also means division. So I could write that as a fraction, 752 kilograms divided by 1 cubic meter. And see how that can help give me an idea of what to do with that final answer to get to our final answer. So it's 752 kilograms for every 1 cubic meter. Yeah, every cubic meter we have will be 752 kilograms. So if I have about 13 of them, I need to multiply 13. Every one of those 13 is going to have 752. So it makes sense to multiply these together. And it also makes sense because the unit of measures will cancel out. You may have learned that before in science class. So multiply that by 752, or in a math class, and you find out that there's about 9,694 kilograms total. Now, how heavy is it for someone in America that doesn't know what a kilogram is? Well, that's when you can actually use the conversion, that there's about 2.2 pounds in every kilogram. Or I think it might be exactly 2.2. So this is how many kilograms we have. There's 2.2 pounds for every kilogram. So each one of those kilograms is going to be worth 2.2 pounds. So I'm going to multiply that by 2.2 pounds per kilogram. The kilograms will disappear, and multiply them together, I find out that it's surprising that it would be that heavy. Geez, I'm almost thinking that maybe the person that designed this question maybe didn't do that great of a job, because it seems awfully heavy. But I'm not a lumberjack. Although I've seen trees fall down on people's houses before and crush their houses. But again, I also don't even know, like a white oak tree, how dense that wood is compared to other woods. Although there might be a question. The next question actually might shed some light on that. But mathematically, that's what the weight came out to be at this tree trunk, which is, well, it's about 20. It's over 20 feet tall. That it would weigh that much weight. Yeah, that's probably about right. I couldn't lift up. I know I certainly could not lift up a tree trunk on my own. And if I figure if a tree had fallen down, you would need to take a chainsaw and split it up. So yeah, maybe this is actually 100% accurate. Maybe it would actually be surprisingly that heavy. So, I mean, like that heavy, like 20,000 pounds. Like you would need a whole street full of people or elephants to help you pull that or try to lift it. Or how about a truck or some sort of, yeah. So apparently, yeah, maybe I'm used to pine trees and maple trees so much. But yeah, the oak tree is, according to this list, one of the more denser types of wood that's out there. It's probably why they make furniture out of it. So it's very durable. All right, so let's actually take a look at question 7. Why don't you answer the question if you haven't, and I will speed right to the end here to show you the answer to question 7. So unpause the video when you're ready, and let's take a peek at how the question was finished. So to determine the density, I need to know the grams per cubic centimeter. The cubic centimeter would be the volume, and a cube has got every side exactly the same. So 6 times 6 times 6 will be 216 cubic centimeters of wood, and they're telling me the weight already. So putting those pieces together to get grams over cubic centimeters, take the weight in grams or the mass in grams and divide it by 216, and you get about 0.64, which on this list here indicates that the wood is most likely ash, which is a type of tree. So, having done all that with you, I will say continue to work really hard and go Sabres. Maybe next year will be the year we finally get back to the playoffs again. We'll see what can happen there. But our playoffs is coming pretty soon. We're getting closer and closer to the end of the year. So continue to work really hard, not only in geometry, but in all your classes. And I wish you a good day. Take care.